In this video, we're going to be doing Finance in Excel Part 3 from your lab book. And in this section, we're going to be focusing on loans, where you are borrowing money from the bank and you are paying the bank interest as a thank you for them giving you the money before you actually had it yourself. Last time when we were doing Finance in Excel Part 1 and Part 2, we were looking at savings scenarios where you were putting money into the bank and they were paying you interest. Whereas in this case, we're doing loans, so you're borrowing money from the bank and you have to pay them interest. So it's a very similar process, just a little bit different. In Part 1 and Part 2, Finance in Excel Part 1 and Part 2, we were using the FV function, the future value function, that told us how much money we would have at a future point in time in the account. That's why it was called the future value function. For loans, we're looking at the PMT function, which is the payment function. And this tells you what your monthly payment is to the bank to pay off the loan, and it includes the principal, that's how much you borrowed, along with the interest, which you have to pay the bank as a thank you for, again, letting you have the money early. So looking in our lab book, we see that we have the PMT function, which is equals PMT, and then there's stuff in parentheses. And just like with the last function, I'm going to put this stuff in parentheses in a column in Excel. So we have APR, N, Y, P, and then our actual PMT function. So APR is our annual percentage rate. N is the number of times per year that you are going to be paying the payment, which is usually 12. We usually make monthly payments. Y is the number of years that you're going to take to pay off the loan, and P is the principal. And in this case, it's how much you borrow from the bank. So our function we're going to do equals PMT, parenthesis, then just like it has in the lab book, APR divided by N, I'm using cell references here, N times Y, and then negative P, and that negative sign is important. So this is very similar to how we set up the FV function, and just like FV, we will give you this formula on your final exam. You do not have to memorize it, but you do need to know how to set up the chart, but it's pretty easy because it's just putting the inputs in order in Excel. So looking at the first example, it says Ricky and Nadia buy a house and they have to take out a loan for $187,500. So that is their principal. That's how much they're borrowing. I'm going to put that in for the principal. It says they qualify for a 30-year mortgage. So let's change years to 30. Fixed rate loan with an APR of 3.75%. So 3.75%. And then it says, what will be their monthly payment? Well, monthly implies paying every month. That means 12 times a year, so N is 12. So Ricky and Nadia will pay $868.34 per month to pay off this loan. So let's look at the total amount that they paid. So they're going to pay the $868.34 12 months a year for 30 years. So they're going to be paying the bank a total of $312,603.02. So if we wanted to figure out how much interest they paid, if we look at the total amount that they paid minus the principal, how much they actually borrowed on their house, they paid $125,103.02 in interest. That's kind of crazy. They borrowed $187,000 and they're paying over $125,000 in interest. They're paying almost as much as interest as they did on their house. It's crazy when you look at the interest that you pay back on a loan. Sometimes it makes you delay gratification and save up the money rather than instant gratification and borrowing, because it costs you so much more in the long run. See, looking at the next example, it says Ricky and Nadia decide they would like to make payments of $1,000 a month on their loan. So we know that they're going to be making a payment of $1,000. Starting with the first payment, how many years will it take for them to pay off the loan? I was asking, how long is it going to take? This is going to be a goal seat question because we're trying to figure out how long it's going to take. So just so you can see it again, I'm going to retype in my formula. So this is my PMT formula. It's going to be APR divided by N, comma, N times Y, comma, negative P. And again, they're telling us we want our payment to be $1,000 a month, and they want to know how long will it take to pay it off if we're paying this extra money. So our APR is still 3.75%, still making monthly payments, and the house still costs $187,500. And the only hitch here is that Excel's giving us an error. You see the pound sign number that's saying, wait, I can't do something. And that's because your years is blank. So what I'm going to do is I'm just going to type in a value for years. Maybe, I don't know, maybe 30. Just picking a number. It's going to change. 30 was the same one from the last problem. But this time, instead of paying $868 a month, we want to pay $1,000. But that's our output. This formula tells us how much we have to pay. We want to change our output to 1,000, so we need to goal seek it, figure out how many years will it actually take. So goal seek, again, it just guesses and checks from whatever starting value you have. So it's going to start at a value of 30, and then it'll probably go down since we're making extra payments and tell us how many years it'll actually take. So I'm going to click on my formula, data, what if analysis, goal seek. Now I'm going to be making payments of $1,000, and I want to see how is that affecting the years. So I'm setting my payment formula to 1,000. That's my new monthly payment by changing the number of years. When I hit enter twice, we see it's going to only take 23.55 years to pay off the house. So we're saving 7 years worth of house payments. It's pretty good. So again, let's look at the total. So now we're making $1,000 a month times 12 months a year times 23.55 years. So the total amount I'm paying, cell's too narrow, the total amount I'm paying is $282,600.23, which means the interest, which is how much I'm paying minus how much the loan was for, is $95,100.23. So look right there, you just saved yourself $30,000 by paying an extra $140 a month on your mortgage. I think that's well worth it. If you're saving yourself right at $30,000 at the end of the time, that's pretty crazy. That's why everyone says make extra payments on your mortgage and credit cards and stuff. Pay them off quicker to save you money. So now we've got 4 more problems. So I'm going to create myself a new chart since we're looking at Meredith and it's a new situation. So again, inside the function it's APR, N, Y, P, and then our payment, which is given by our PMT function, parenthesis, APR divided by N, comma, N times Y, comma, negative P, close parenthesis. And I'm going to go ahead and drag this over 4 spots since we have 4 parts with Meredith, and that way I'm not losing anything as we do each problem. So it says Meredith is buying a $225,000 house. She will make a 15% down payment on the house and finance the rest. All right, so this is actually a little bit different. She's not borrowing $225,000, so I'm going to delete that for a second. So let me just go down here somewhere. So it says she's making a 15% down payment. That means she's going to be paying 0.15 of the house up front. So she's going to be laying down $33,750, which means she's actually borrowing $225,000 minus that amount. Her loan is only going to be for $191,250. So I'm going to put that as the principal of my loan because she's already paid $33,750 in her down payment. So she's financing the rest. That's $191,000 number. It's going to be a 30-year fixed rate loan of 5.795%. And I don't want Excel to round that. Let me up my decimals. There we go. Monthly payment is 12. So Meredith will be paying $1,121.56 a month. So just because it's amazing, let's calculate the total amount she pays and then figure out how much she pays in interest. So the total amount she pays is her monthly payment times 12 months a year times 30 years. And her interest is going to be her total paid minus how much she borrowed, her principal. And look at this, she's paying $212,000 and some odd cents in interest when she only borrowed $191,000. In this loan, she will pay more in interest than the house actually cost. It's crazy. All right, next one. It says Meredith is considering a 15-year fixed rate loan. So now we're looking at 15 years with an APR of 5.5%. Compute the amount of monthly payment for the loan amount, same as the previous problem. So let's see. Actually, N is still 12 monthly. 15 years, there we go, and then the loan amount is still $191,250 because she made that 15% down payment. And since I use cell references, I should just be able to drag these over. Oh, you know what? I didn't use cell references for this one. So this one, it's our monthly payment times 12 months a year times 15 years in this case. There we go. That looks better. So in this case, she is paying a total of $281,280.98. And of that, the $191 goes towards the principal and $90,000 goes towards the interest on the loan. So that's a huge difference. If she can manage to make basically an extra $400 a month in her payments, so monthly payments higher, pay off the loan in 15 years instead of 30, look at how much money she saves in interest. She saves over $100,000 in interest. That is big time money. So if you're looking at buying a house, it's worth it to pay a little bit more every month and save all that long term than it is to try to stretch out your payments and you actually end up paying a whole lot more in the end. And then we do have to keep in mind she's already paid this $33,750 up front. That was her down payment. So these numbers are how much she's paying on the loan and how much she's paying on the interest to pay off the loan. All right, the next part, it says Meredith decides to go with a 30-year loan, but she wants to make payments of $1,500. How long is it going to take? So it says that she's setting up this 30-year loan. I don't know why it keeps rounding that. So monthly payments. But the difference here is she's going to be paying extra. Instead of making the monthly payment of $1,121.56, she's going to pay extra. She's going to pay $1,500 a month, and she wants to know how long is it going to take. So we need to goal seek it to answer that how long question. So we're going to goal seek our formula to how much she's going to pay, the $1,500, by changing her years. And so if she pays extra on this mortgage, she's going to be able to pay off in 16 and a half years, basically. So her total will be her monthly payment times 12 months a year times the 16.54 years. And she will have paid $106,000 and some change in interest. So what's really interesting is comparing the 15-year loan versus the 30-year loan where she made extra payments. So the 15-year loan, you're forced to pay the $1,500 a month, and you pay it off in 15 years, and you save yourself a lot of money compared to the 30-year loan. But if you take out the 30-year loan and you pay extra, you're in almost as good of shape. You pay a little bit extra in interest, about $15,000, $16,000 extra, but that's way better than over $100,000 extra. And this is what a lot of people do. They try to get a long loan and then pay extra on it, but because the bank isn't forcing you to pay the extra, sometimes people get slack and they don't, and it ends up costing them more in the long run. So you just need to be aware when you're buying a house and know what you can afford and what will be best for your family and your financial future. And then the last one, it says Meredith can only manage monthly payments of $1,000 on a 30-year fixed rate mortgage. What interest rate would the loan need to charge for her to get this? So again, she's borrowing $191,250 monthly payments, and it's saying what interest rate would she need to get to have a $1,000 a month payment. So we need to goal seek our payment to $1,000 a month. So we need to goal seek to $1,000 by changing our APR. And I'm going to change that to make it look pretty. I'm going to change it to a percent, to 3 decimal places. So she would need an interest rate of 4.77% to have $1,000 a month payments over 30 years. In this case, her total payment would be the $1,000 times 12 months a year times 30 years. And her interest paid would be her total minus her principal. So $168,000. So still way more in interest for making the minimum payments on a 30-year than having the minimum payments on 15, or by paying extra on the 30-year mortgage.